Okay, today I'm going to talk about GCF and LCM. I'm going to start out by talking about the explanation of how to do GCF and give you an example, explanation of how to do LCM, and an example. I'm then going to explain the difference between factors and multiples, and then I'll do a couple more word problem examples. So let's just get started. First of all, GCF. In order to find GCF, you find all the factors of the numbers, and then you circle the common factors and identify the GCF. So if I wanted to find the GCF of, say, 6 and 12, what I would do is I would make a list of all the factors. 1 times 6, 2 times 3, and I think that's it. Over here, 1 times 12, 2 times 6, and 3 times 4. And then I'm going to circle all the common factors so that I know kind of what are my common numbers that are in both lists. 2 is in both lists. Looks like 3 is in both lists. And 6 is in both lists. So my greatest common factor, my factors are 1, 2, 3, and 6. Those are my common factors. The GCF is 6, because it is the greatest number that appears in both of these lists. LCM, I make a list of all the multiples for each number, and then I stop when I find a number that appears in both lists. So I'm going to make a list of all the multiples of 6 and 8. So 6 is going to be 6, 12, 18, 24, 30, and I'm just going to stop there and go over here and see. 8, 16, 24. I can stop right there because now I've got a number, the least number that appears in both lists, and that is 24. So that's the LCM. In order to kind of talk about the difference between factors and multiples, I want to show you kind of all the factors of 12 and then some of the multiples of 12. So the factors of 12, we've already done these a couple of times in this video, are these: 1, 12, 2, 6, 3, and 4. The multiples of 12, 1 times 12 is 12, 2 times 12 is 24, 3 times 12 is 36, 48, 60, 72, and I could keep on going forever. But what I want for you to kind of notice is that all of these numbers are either 12 or less. All of these numbers are 12 or greater. Okay? When you are finding multiples and factors of numbers, factors are all numbers that your number, the number you started with, is divisible by. And multiples are all the numbers that you get when you multiply that number. So factors of 12, to find factors you divide, to find multiples you multiply. That kind of makes sense because the word multiple sounds like multiply. So I'm going to go through and kind of do this example, and I've already completed it, and I'm just going to talk you through kind of what I've done here. 2 ships sail steadily between New York and London. One takes 12 days to make the round trip, the other takes 15 days. Both are in New York today. How long until they are both there again? The good thing about when you see LCM and GCF questions is that really they just require a little bit of common sense. Okay? If you think about whatever the situation is that's being described and you think about it in real life, you're going to be able to come up with the answer. For example, on this one, well, this ship is there today. They're both in New York on kind of day 0, which is today. Then in 12 days, this one will be there again, and it'll be 15 days before this one's there. Then this one will go again in 24 days, and 36, and 48, and 60. This one will go again in 30 and 45. So they're kind of missing each other by a few days. And then in 60 days, they'll both be there again. So the answer to this question is 60 days. They'll both be there again in 60 days. Now, when you have that information, you can kind of realize, well, those ships are going to be both in New York every single 60 days. They're both going to be there every time 60 days comes. They're both going to be there because this is a pattern that they keep on repeating. Okay? This question, another LCM question. John is buying markers and paper. Paper comes in packs of 20 and markers comes in packs of 10. How many packs of each should he buy so that he has none left over? So we're buying markers and paper. Paper comes in packs of 20. Markers comes in packs of 10. Well, this is a little bit of a trick question because the LCM of these two numbers is 20. But that is not what the question is asking. The question is saying how many packs of each should he buy so that he has none left over? It should say what is the least number of packs of each he should buy. So he can buy 1 pack of paper, 2 packs of markers, and he'll have kind of 1 marker for each sheet of paper. And that's what this question is looking for. GCF questions look a little different, but they're still mostly common sense. Lydia has 12 folders, 18 markers, and 9 pencils. She wants to split the supplies into equal groups and put them on tables. What is the greatest number of tables that she can prepare? Well, that word greatest is in the problem really kind of signals you off that it's a GCF question. So I'm going to go through and I'm going to list out all the factors of all these numbers. And then 2 times 9, and looks like 3 times 6. And then 1 times 9, and 3 times 3. So those are all my factors. My common factors are 1. 1 will always be a common factor in every single set of numbers. Note 2 is not common because it's not over here in this list for 9. So I should not have circled 2. I'm going to go back in and fix that. 3 is common because it's in all 3 lists. And then the only other number, let's see, 6, no, is in these 2 but not that one. 9 is in these 2 but not that one. So there is no other number. So she can prepare 3 tables. And on those tables, she'll have 3 pencils, she'll have 6 markers, and she'll have 4 folders.